Now, vectors in the Cartesian. Of course, as you know, physics and mathematics are brothers. You can't use physics without mathematics. And let's assume we have a Cartesian here, and we have all those squares. Each square represents a unit. Then we have vector A head to toe to vector B, and we have the resultant C. Now, we need to know that on the Cartesian, you can't only tell just one value for the magnitude of the vector, but it needs to be two values, because as you remember, we have Cartesian is x and y axis. So for vector A, this is the x axis and this is the y axis. For vector B, this is the x axis and this is the y axis. So keep that in mind in deciding the value of A, B, and C. So for A, at the head of A, on this x-axis from the origin over here, it moved 5 units, and it moved to the y-axis 1 unit. And for B, if we go over here, he moved to the right from his origin over here, or from his tail, he moved on the x-axis 1 unit, and on the y-axis it moved 4 units. In this case, we can decide C as equal to A plus B, and if we do A, in this case, is 5 and 1, plus B is, in this case, 1 and 4. So, that's the X, that's the Y, that's the X, that's the Y. So we add the X's together and the Y's together. That would give you C value in terms of X and Y. 5 plus 1 equals 6. And 1 plus 4 equals 5. So the location of C would be from the origin of C, which is over here, would be 6 and 5. So in this case, you found the magnitude of the vector C on the Cartesian or on the XY axis. So A equals 5 and 1, B 1 and 4, and A plus B gives you C as 6 and 5. Now let's talk about motion in 2 dimensions. Remember before we said velocity is a directional value. That's why we said it has an arrow above it. That means it has a magnitude and a direction. Same thing for acceleration. So in terms of X and Y, we can represent the directional V as Vx and Vy. So you're talking about a value on the x-axis and a value on y-axis. Vx and Vy. So if we had a vector V going from this point all the way to this point, and reference to the horizon from the math, you have an angle of theta over here. Now the V is going in this direction. It's not on the x-axis, not on the y-axis, but in between. So I can imagine this as y-axis, and I can imagine this as the x-axis, and this is the origin where the vector started from. Now to find Vx and Vy, we need to break this vector into horizontal component and a vertical component. Going to trigonometry, we know that V component on the x-axis is V cosine theta, and V to the y-axis is V sine theta. Now Vx can be represented or simplified around. Either it will equal V cosine theta or equals Vy tan theta, and Vy can be V sine theta or can be Vx tan theta, just for playing around with the equations. And V can be Vy over sine theta and can be Vx over cosine theta. All of these are true, and you can use them based on the problem that's in front of you to be able to find the variable that you're looking for. Now again, vectors components. Let's say somebody moved from here to here. The magnitude of this vector was 150 meters. So we had a motion, we had a movement over here, and this movement going in this direction, and it has this value of 150. if we want to find the Vx, let's say we want to find the Vx component or the x component of it and the y component, let's say we don't know those values, we want to find them. By knowing the angle that he moved with, can be easily finding the x component and the y component. So in this case, let's say this is V. Based on what we learned, Vx equals V cosine theta. In this case, the value of V is 150 cosine whatever theta or whatever angle we have. That would give you this value. But that's not the topic. Let's try to revise some of the needed math with vectors. Firstly, we have trigonometry. So we have a triangle over here with an angle of theta. So we have the adjacent, and we have the opposite, and we have the hypo. Keep that in mind. And the sine of theta would be opposite over the hypo, and the cosine is the adjacent over the hypo, and the tan would be the opposite over the adjacent. So we have a vector over here, starts from the origin of the Cartesian, ends at his tip. His value is A. He takes an angle of theta. What is his x component and y component? You will get that question a lot while you're learning about vectors. So we know that AX equals A cosine theta, and AY equals the value here, A, and it would be sine theta. That's an A. As simple as that. That's all the math you need, at least for the coming 2 lectures. Now let's come back to the hockey field or football field over here. We start from origin 0 and 0. Why we say that? Because that represents x and y. We're not moving anywhere. We're at the original of 0 and 0. X component represents this side. Y component represents this side. Again, as I told you, if we had the theta and we already have the magnitude of V, then we can find the y component and the x component in no time. Let's get a vector component example. He say determine the north and east velocity components of a car traveling 100 kilometers per hour. So there is a car. Let's draw always a Cartesian at first. You have x and y, so you know where you're going. It's going 100 kilometers per hour with an angle that's given to you over here with 25 degrees. Forget about this sign. So you have 25 degrees angle over here. That represents theta that we talked to you about. So now I know that the value of the velocity is 100 kilometers per hour. The value of theta is 25 degrees. Now find, in this case what he's asking you, find Vx and Vy. As simple as that. Now Vx would be V multiplied by cosine theta. V we already know it's 100. Cosine theta is 25. Use your calculator. You will find your final result as 90.6 kilometers per hour. Remember always to keep units consistent. Vy would be V sine the theta. And that would be 100 kilometers multiplied by sine 25. That would give you 42.3 kilometers per hour.